So in this video, we're going to just talk about what waves are. So waves are really cool because they're a way to transfer energy between two places without transferring matter. And we're kind of used to transferring energy, but through transferring matter. So I can pick up a ball and throw it at you, and you will gain some kinetic energy, but that's because I threw a ball at you. And the ball had to move across the air and hit you in the head. So in a wave, the energy will still be transferred, but it will do so without necessarily transferring matter. So in this picture here that I have, this beautiful picture of stick figures, I have this blue line representing like a jump rope or a slinky or something. And how I'm imagining it, the person on the right just kind of whipped their end, which sends this wave down the rope, and it's about to hit this person in the face. And the thing to remember is that the part that hits them in the face is the part that's already next to their face. So the part that's right under their chin might hit them in the chin. But it's not as though you're taking your end and throwing it at them, right? All you're doing is you're transferring energy through this slinky, and that energy eventually gets here, and then it goes into them. And so the initial thing needed for a wave is a disturbance, right? Energy has to be put in, and then it can start to travel. So that initial disturbance in this example is this person on the right whipping the slinky or something, or that could be someone plucking a guitar string, or making a wave in the water, dropping a pebble in water, whatever. So that's your disturbance. The second thing that you need is a way for the energy to be transferred. So in mechanical waves, which is what we'll be talking about for this first part, a medium is necessary. And a medium is just the substance that's going to carry the energy. In this example, that medium is the slinky. And if you're dropping pebbles into water, the medium is the water. If you're talking about sound waves, the medium is the air. And that's just kind of what's carrying the energy as it goes. Another important part is that the medium needs to have some kind of restoring force or equilibrium, something like that. And what I mean by that is that if you disturb the medium will kind of want to, or there'll be a force on the medium to return back to equilibrium. So you're going to move it out of equilibrium and it's going to go back. But as it's going back, it has to transfer energy to an adjacent part of the medium. So this slinky wouldn't work if I had chopped it all up into little bits here, because I need the initial part next to my hand to transfer energy to the next part, which transfers energy to the next part, etc., etc., etc. So we need a disturbance that adds energy in, we need a medium, and we need the medium to be able to transfer the energy along its different sections. And you can think about that as it moving out of equilibrium and then back, and giving that energy to the next section. A really useful illustration of this is like the stadium wave. So if you have a stadium wave and people are, it kind of comes to you and you stand up and you go, ah, right? In that circumstance, the medium is the people, you, and you can see that you're not moving from left to right in the stadium. You're just going up and down in your seat. And that again is that energy is being transferred, but matter is not being transferred. And that's kind of an analogy that you can use. So let me show you this real quick. Here's the website here. And this first animation is for longitudinal waves. And longitudinal waves are waves where the disturbance, right, the change, the displacement from equilibrium, is in the same direction as the direction of the wave. Okay, so here if you look at any of these dots in particular, you'll see that they're only kind of moving back and forth left to right. And that once it hits another one, kind of transfers its energy and goes back. And that only when you kind of zoom out and look at all of them together does it look like you can see these distinct waves moving from left to right. And what you're seeing is that energy that's moving from left to right. But you'll notice that each individual dot kind of stays in place, right? No dots from over here end up over here. And this gray bar over here is our disturbance that's kind of pushing these dots along. The second type is transverse waves. And the only difference here is that now the displacement is perpendicular to the direction of the waves. The wave's going this way, but now they're moving up and down instead of left to right. And that's a transverse wave.